Hey y'all, we're back for nomenclature. Again, nomenclature meaning a fancy word for naming compounds. Today, or this video, because it's still the same day, we're in the same clothes, we're going to do ionic plus a transition metal. So the transition metals I have bolded here in black, okay? So they're going to be this big section in the middle of the periodic table with any non-metal, okay? So again, that's going to be a transition metal with a non-metal. The way that we name this is element, Roman numerals in parentheses, elementide. So the only thing that's new here, different from the simple ionic, is now we have these Roman numerals. Our first example, we have Fe2O3, okay? So that means we have 2 irons and 3 oxygens. However, remember that before, if I gave you Fe plus 3, O minus 2, we would have to crisscross these, and that's how we got Fe2O3. So in a situation like this, if we uncrisscross them, we see that the 3 belongs to iron, the 2 belongs to oxygen. Okay, so we uncrisscross them and see where they belong. So we have iron oxide, that should make a lot of sense, but then we have to put the number that belongs with iron in the middle. So this is going to be iron 3 oxide because that 3 belongs with iron. A few more examples so that you can see this. Let's look at VF2, okay? So, if I take VF2, I need to uncrisscross it, okay? So the 2 comes over here. Remember, this is like an implied 1. That V wouldn't be there if there wasn't at least one of them, just like X in your math class. So that means when you uncrisscross them, we have V plus 2, F minus 1, okay? The metal will always be positive because metals form cations. The nonmetals will always be negative because nonmetals form anions. So we have V2F1. So we're going to name that vanadium because that's the element. Roman numerals, whatever number is with that metal, and then elementide, sorry, I gotta write it down here, fluoride. Easy enough. We'll do a couple more. Okay, what if we do COCl2? Okay, COCl2. So, uncrisscross them, and we have CO plus 2, Cl minus 1. Okay, so CO, right here, cobalt, and then we have to put that number in Roman numerals. Spelled that wrong. Elementide. Okay, so we have element, elementide, same thing as simple ionic, but we got to put that number that belongs to the metal in the middle. So that's the charge of the metal. Okay, a little bit of a trickier example is going to be VO2. Alright. Now, in situations like this, it might look like it's going to be V plus 2, O minus 1, but that's wrong. That has to be wrong because we know, and you all need to know this, that oxygen has a charge of -2. Okay? So if we know oxygen is -2, and there are 2 of those, then that means that the grand total is going to be -4. Therefore, this 1V must be +4 because we need those to be in equilibrium. We need them to cancel each other out. So, that means that +4 is going to be the charge of vanadium. So that's going to be vanadium 4, that's how you write 4 in Roman numerals, oxide. Okay, that one's a little bit more tricky. So again, what I did is I saw that there are 2 oxygens. I know that oxygen has a charge of -2. So I wrote both 2's out, put the -2 on there, and I know the total of oxygen, because there's 2 of them, the total has to be -4. And then if that's -4, we know vanadium must be +4 in order to neutralize that or cancel it. So that's how I found the charge of the vanadium in this situation. Let's try another example like this. If at any point you feel like you need to pause the video and listen to my explanation again, please do that. That is the bonus of online learning, is you can listen to me as much or as little as you would like to. Okay, so another example that's going to look like that is ZnS. Okay, so I have one S, okay, the charge of S is -2, so I know that that's -2, which means this Zn needs to be +2, okay, so because of that, we then know that the name is going to be zinc 2 sulfide. Zinc 2 sulfide. If you need a quick recap on how to know what the charges of everything are, they are going to be above the columns. So +1, +2, +3, ±4, -3, -2, -1, 0. Okay, let me bring you a little bit closer so that's easier for you to see. Okay, so you can see the charges of all of those. If you want to pause and write that down yourself, feel free. Alright, so that's how we know the charges of everything. So that's based on the column, right? So everything in this column is going to have a charge of +3. Everything in this column is going to have a charge of -3. Okay, and so all of those are going to be like that. Okay, I'm going to give you 3 examples to do on your own. Okay, so the 3 I would like for you to do are AgBr, Mn2S5, and ZnO. Okay, I'm going to give you a few seconds to pause the video. Okay, so hopefully you paused the video, you thought about what the names of these are, so I'm going to write them down for you. So here we have silver 1 bromide, silver 1 bromide. Here I have manganese 5 sulfide. And here I have zinc 2 oxide. Okay? If you need help with any of these, please be sure to come to office hours, ask questions when needed. Have a great day, y'all. Take care.